Yeah, hello students. We are going to just have a good idea about what are the things to be learned in the topic of kinematics. So it's chapter number 4, motion in a straight line. You have already done this one. We have given 2-3 tests in this particular chapter, but I'll quickly give a overview about what you will learn. Syllabus is already given here. You can just take a look on it. The first few pages which is given here, it is just for reading sake. You might know many of the definitions like velocity and speed. These all the definitions you would know, so you need not really spend time on learning those things, and straight away you should go to a quick glance about the time displacement graph. So time displacement graph has a few of the graphs, which is the greater the slope, how this will be. So one it will be displacement and time graph, and then as well as the same uniform velocity, and as well as the negative slope of the graph, how it will go. You can just take a very quick look. Don't spend much time. These are not the ones to be spending more time. Then the straight thing that you will go to is page number 111, time velocity graph. So this also has a quick understanding about the velocity time graph. Is just an area of the graph. So you will have an area of a graph which is given as the distance traveled, the displacement is going to be equal to velocity into time. So based on that, there is only numerical in this one. So there is nothing much to learn as a theory portion. It is mainly a numerical part of it. And once that is over, then you will have a slope of a graph. You will get an acceleration of this one. So whenever you get the slope, you will get the acceleration. Acceleration is going to be velocity upon change in velocity upon time. This is the particular thing. And if you have an increasing velocity, what happens? Velocity increasing, and as well as when there is a decreasing velocity, what happens? So this is the two forms of this one, which is there clearly. Don't spend much time once again in this particular thing. Just give a glance and keep moving on, because these things are just a part of your very much what you learned in the lower classes. Now in this particular thing, the main thing is the equation from uniformly accelerated motion. So there are 4 equations of motion. So the 3 equations of motion plus this one. Graphical method, the derivation of this one in graphical method, it will not come in examination. Please don't spend time on graphical method. So there are all the 3 equations are given in graphical method here. Page number 115. Please don't learn this, right? So this is not the very important thing. Quickly give a glance on the graphs alone. Now the main part is derivation of equations of motion, accelerated motion using calculus method. This is very important. All the 3 equations, v is equal to u plus at, how it comes, s is equal to u plus half ad square, how it is derived, and v square minus u square, u square minus u square is equal to 2as, how it is derived. These all 3 derivations are very important. Alright, and then s is equal to ut plus half ad square, sorry, the distance traveled in the nth second, I derived not in the calculus method. I have not derived in a calculus method. If you go back to the book and see, yeah, I didn't derive this one. But before going into this kind of stuff, first of all, you should understand, before going to this calculus method at all, please take a look on what we have done as differentiation. So differentiation. So we did a lot of things of differentiation, and then integration. So these 2 things we did, quite a lot of things we did. And after we did the differentiation, then also we did about how it is the value of velocity. Velocity is going to be equal to dx by dt. We already did this one. And acceleration is going to be equal to dv by dt. We had done these 2 things very much carefully. So whenever you have a displacement formula, maybe you have here t square minus 5t plus 3. If this is the displacement value, then we can find the velocity. How to do the velocity? ds by dt. You can differentiate this expression. Once you differentiate this expression, what it will become? 2 will become to here, 2t, and then this is to the power of 1, it will become minus 5. So that is velocity. So differentiation, you have already done it quite a lot of times. So please remember to revise all the differentiation questions. We had done so many of differentiation varieties. But mainly, if you don't want to revise everything of differentiation, just revise these things: velocity, acceleration, and displacement. Right? So suppose this one we again wanted to differentiate. If you wanted to have acceleration, differentiate this dy by dt. So what will be this one? It is 2 to the power of 1. 1 will be multiplied here. It will be just 2 is the answer, because this will become 0. So another question I would like to put, so that it will be a little more clear for you. I'll just put one more question here. If it is distance is going to be equal to t cube minus half t square minus 5t plus 4. This is the expression, right? Maybe I will put 2 here also. So what is dv by dt? Differentiation of, ds by dt, that is going to be velocity. Differentiate this one. 3 will go here. It will become 6. T to the power of 3 will be deducted by 1. So it will become t square. Minus. This will come here. Half into 2 is coming to the front. 2. And t to the power of 2 will be deducted by, reduced by 1. That power will be deducted by 1. T to the power of 1. Minus. This minus is there. 5. Constant you put 5 here itself. T to the power of 1. The t to the power of 1 will be multiplied here. So it will be 5 itself. And t to the power of 1 minus 1 deducted by this one, it will become t to the power of 0. Plus this one will become 0 here. So finally what happens? 6t square. This 2 and 2 gets cancelled. Minus t. Minus t to the power of 0 is 1. So it becomes 5 plus 0. This whole thing is not there. That's velocity. Now moving further, you can find out acceleration. Acceleration is equal to dv by dt. Differentiate this one once again. You will get acceleration. So 2 comes to the front. So 6 into 2 is 12 into t to the power of 2 minus 1. You reduce the power by 1. So it will become t to the power of 1. This is already to the power of 1. So this power comes to the front 1 into t to the power of 1 minus 1. Minus this 5 will become 0. So it is going to be 12t minus 1 t to the power of 0. This will become t to the power of 0. T to the power of 0 is already 1. So it is only this much. That's going to be acceleration. So you should be able to understand how it is. Now if it says find the acceleration when t is equal to 3 seconds. So you can find out the acceleration when t is equal to 3 seconds. So now 12 times of 3 minus 1, it is 36 minus 1, it is 35 made up by second square. You'll be able to make this kind of a calculation and then find out. Suppose if they are say at when the acceleration is, suppose if this is not the one, for example, this is not the one, what is the time? When will acceleration be equal to, maybe it is equal to 0. When will acceleration, when means time is equal to question mark, when acceleration is 0, so a is equal to 0 you put here, equal to 12t minus 1. So what is the value of t? It's going to be equal to 12t is equal to 1. So t is going to be equal to 1 by 12 seconds. So at that particular time acceleration is going to be equal to 0. Something will be there. You can try to find out this way also. So I'm just giving an idea about how to do the differentiation. Okay. Hope you would understand this. And also write definitely these 3 equations of the motion and also this one nicely and properly and do it. Next one is integration. When you do integration, how the integration takes place. So a quick recap about how this integration takes place. Suppose if you have a value as, now integration is the reverse process of differentiation, right? So if you have an acceleration value is there, maybe t square minus 2t plus 5. If this is the value is there, acceleration, you can find out the velocity using this one. How do you find out the velocity? So you know acceleration is going to be equal to dv by dt. So how to find out the velocity? dv is going to be equal to multiply this one here, a into dt. So dv is equal to a into dt. Now this acceleration, whole thing, you put it here because this is a. This a, put it here. So dv is going to be equal to t square minus 2t plus 5 times of dt. Right? So you are going to integrate on both sides. Integration of dv, t square dt. This has been multiplied inside. Minus 2t dt. This also multiplied here. Plus 5 dt. And now integrate in everything you need to integrate. So this will become v. This will become v. What will this will become? T to the power of 2 plus 1. You need to add this 1 upon 2 plus 1. Minus 2 to the power of t also to the power of 1 is there. 1 plus 1 upon 2. This same power you need to put here. Plus 5t. This will become only t here. So what is the value then? T cube upon 3 minus this 2 and 2 gets cancelled. T square plus 5t. That is velocity. So you can find from acceleration, you can find out velocity. Whereas this is an integration. This is the integration. You have done the integration part of it. What do you do in the reverse side? When you have velocity, you can find out acceleration. From velocity you can find acceleration, you need to differentiate. From acceleration, you wanted to find velocity, you need to integrate, reverse process. Now, from here, still you can find out the displacement also. How to find out displacement? Velocity is going to be equal to ds by dt. So what is ds is going to be equal to v dt. Right? So this whole thing, you put it here. That is velocity. That velocity put it here. So ds is going to be equal to t cube by 3 minus t square plus 5t whole dt. Now differentiate. Integrate it. Integrate this one, you will get displacement. So this is also this ds is going to be equal to 1 by 3 t cube dt minus t square dt plus 5t dt. Everywhere put integration. So what will this will become? 1 by 3 into t to the power of 4. Add this one upon 4 divided by the same power will be divided. This is also t cube by 3. This is increased by power, that same thing. Plus to the power of 1, 5 to the power of t square by 2. This power is increased. So it becomes t to the power of 4 by 12 minus t cube by 3 plus 5t square by 2. That is displacement. Alright, you can from acceleration you can find out velocity. From velocity you can go to differentiation, displacement. These are all coming by a integration method. Hope you know this one. So please sum up all of them. So in the first part of the whole thing, it is just the 3 equations of motion by differentiation integration method, and then the distance displacement travel in the second, the distance travel in nth second. So that part of it, that's all. And then the numerical starts. So do all the numericals. There is a lot of graphical portions are given there, and as well as the differentiation numericals also is given there. You have got so much of numericals you've done. So please do that, and try to cover up this numericals also which has been here. Right? You will be able to have a good idea about what it is, what are the things to be learnt, and also the based on the vertical of gravity, how the gravity works, and many numericals have been given here. Please do this. You will be able to have a good idea about how to go about this. Right? In the next video I will tell about how to do the next part, that is the vectors, motion in a plane. I'll do this one in the next video. Thank you.